Hello, everyone, and welcome to another episode of Arthritis at Home. My name is Ellen, and today I'm joined by a special guest, Natalie McCormick. Natalie is now junior faculty in the Division of Rheumatology, Allergy and Immunology at Massachusetts General Hospital and is mentored by Arthritis Research Canada scientist Dr. Hyon Choi. Natalie completed her Ph.D. training at Arthritis Research Canada in Vancouver. Natalie, it's wonderful to have you. Thank you for joining us today.
Thank you for this opportunity.
Natalie, I know we had saw each other at the EULAR 2024 Congress, and Natalie, you had several presentations there, which we'll get into in a little bit. But Natalie, tell us about yourself and how you're involved in rheumatology.
Hi, yeah, so thanks for having me here. And as you said, I first got into rheumatology research as a grad student at UBC and Arthritis Research Canada. My grad student research was about the economic burden of lupus and related systemic autoimmune rheumatic diseases. So looking at direct medical costs and also at the impact of lost productivity. So being less able to do both paid and unpaid work. And a lot of that research involved using sort of large databases, and I was kind of exposed to epidemiology. So for my postdoctoral research, I wanted to learn more about epidemiology and sort of risk factors and potentially, making some causal conclusions about causes of diseases. And so I had the opportunity to go to Boston and do some training with Hyon Choi. And so I've been there for a few years and as a postdoc and now as junior faculty.
Well, congratulations, Natalie, on your new role. And, I do want to emphasize to everyone, Natalie has an incredible publication record. She is very productive was when she was in her PhD and continues to be. And Natalie, so you made this switch from lupus, looking at lupus in large data sets and calculating the medical costs associated, as well as the large, specific loss in productivity. And now you've pivoted to gout. Can you, help the audience understand what is gout and perhaps who's at risk of developing gout?
Yeah. So it's been a switch in some ways in that, lupus is the most common of the SARDs, which is the group of disorders I was studying, but it still affects, a relatively small number of individuals as compared to gout. Gout is actually the most common form of arthritis. It affects about 5% of US adults and probably a similar proportion in Canada. I don't have the latest numbers handy. It predominantly affects men, whereas lupus predominantly affects women, although, many women do develop gout. And it's sort of characterized by having very painful attacks of joint inflammation that, can be quite disabling. People are often, unable to move the joint, can have trouble, walking and performing their daily activities. But even when those attacks resolve, there can also be many systemic consequences. So like other rheumatic diseases, including lupus, gout is associated with increased risk of cardiovascular disease and diabetes. So I found that there's lots of interesting things still to study in gout.
Absolutely. And Natalie, your work is very much so groundbreaking in the fact that, no one has looked at this previously, especially not in these large data sets that you're looking at. So could you, help myself as well as the audience understand a little bit more about when you're talking about epidemiology and these large data sets, what are you doing with these large data sets? Perhaps where are the large data sets from, and why are they such a rich and powerful source of information?
Yeah, so there's different types of data sets in what I use for my thesis work, and we still continue to use from Canada is the large administrative data sets. So those are the healthcare utilization mainly, and that can tell you about when people are diagnosed with diseases, when they use certain medications, and what the consequences of that may be. And we use some of those too from the US. Difference between Canada and the US is that, US doesn't have the sort of single healthcare payer. So you end up having to work with different data sets. Medicare, which is usually like the older population, that certainly is a more relevant data set for gout. But also, different commercial health insurance plans have their own data sets. And we also use large data sets from prospective cohort studies. So when they've, enrolled a large group of people into a study and follow them for long periods of time, and that can be a better way as opposed to the healthcare databases in terms of collecting information on environmental factors, dietary exposures, lifestyle factors that can contribute to disease. And can often have, blood samples are available, and you can look at lots of different types of data. And so we use that from the US as well as from the UK. And an advantage, epidemiology isn't like a randomized trial in that you aren't, prospectively assigning people an intervention. So it's harder to make causal conclusions, although, we're starting to be able to do that with some of our statistical methods. But the advantage is that, you get really large sample sizes. You can follow people over much longer periods of time than you can within, the confines of a randomized trial. And, when you're doing a randomized trial, you're often very restricted about the population that you enroll in the trial, that they have to, maybe be at a certain stage of disease. They maybe can't have other types of diseases because you want to get a really focused look at, maybe whether a treatment's going to be effective. So the large data sets that we use in epidemiology can be considered more generalizable, and the findings can certainly complement each other. And for example, if for medication safety research, you tend to look at a trial to see the efficacy of a drug. Is it going to have that primary effect in terms of helping or preventing something? But then you look at the large databases over sort of a longer period of time over what those harms may be that you can't see in a trial setting as easily.
Natalie, that's so interesting. I think you bring up 2 points that I haven't considered previously. The first being that you're right, you're working with multiple different data sets. When we say, large data sets, it can be multiple, they can be different in nature, but using them in complementary ways, perhaps trying to combine them if appropriate. I know that takes a lot of work on the back end for cleaning these large data sets to make sure that they are able to be used together. But also, it's true, these large data sets, because they are large and perhaps they follow people for longer periods of time, they do start to reflect real life, right? That generalizability, meaning that the research we do is actually a reflection of what happens to patients in Canada, in the US, these data sets that you're looking at. And I think it's really interesting to note that when you're looking specifically at, as you said, the adverse events, right? We actually would use the large data sets. And that's, I think, the appropriate thing to do. So thank you for teaching us that, Natalie. I didn't know that previously. My next question for you, I would love to know a little bit more about, you presented several abstracts, posters, presentations, oral presentations at EULAR. Could you share maybe an overview or highlight a few of the findings or the projects that you had done to learn more about gout and some of these outcomes that you're looking at?
Sure, yeah, and I realize in looking at them that it's almost like a mini portfolio of some of the work I've been doing recently. So a couple of them were about potential factors that are predictive of developing gout.
Yeah.
And so this was more some of the more recent work that I've been doing here at MGH. One of them was metabolomics. So those are some of the metabolites that exist in the blood, different lipids, different amino acids. And that was sourced from the UK Biobank, which is a large data set of sort of middle-aged adults and looking at development of diseases over time. And so use that data to identify certain amino acids that actually seem to be associated with reduced risk of developing gout. And a lot of the studies, this is another difference between the large data and the clinical studies. There's been some smaller scale studies done at clinics about metabolites that might be associated with gout, but they tend to be more cross-sectional. So looking at metabolites that are more common in people who have the disease at that time versus who don't. And a similar study that I did also using the UK data was about proteins that were associated with the development of gout. And that was also, sort of can help with some mechanistic factors, looking at pathways that seem to be associated with gout risk. And, a lot of the findings were kind of consistent with knowledge from other areas in terms of factors that seem to be associated with the development of gout flares specifically. And then I had a couple other, I had a presentation and a poster, and that was using the data from BC, and that was among individuals with gout and use of some of the new diabetes medications, and how that one of them was on how these SGLT2I, so one of the new classes of glucose lowering medications, can help reduce gout flares. And another one was showing that use of those medications may actually reduce kidney stones, particularly among individuals with gout. And that's another example of how gout is associated with a lot of other conditions, including higher risk of kidney stones. So, there could be dual benefits, potentially even sort of triple benefits, because, these medications are officially indicated for diabetes. So could help with gout, diabetes, and even kidney stone.
That's so interesting. And I'm going to repeat that word for our audience. The word is metabolomics. Am I correct?
Yeah.
Saying that?
Yeah. So metabolites, blood metabolites, if that's easier.
Studying the blood metabolites. So these are molecules, or I should say, these are things in our blood, right? That can act as either, I'm going to use the word protective factors. Is that correct, Natalie? They can either protect us, or these factors would be upon a causal pathway, or these would be not good for our health, right? These could contribute to the risk, right? These are risk factors. So they can be protective, or they can be risk factors for gout. And the interesting thing from your work is we're really seeing a connection between metabolism, right? In this case, you looked at diabetes medication in BC, specifically the use of newer diabetes medication, and the improved risk. So even though people are taking these medications for diabetes, they're actually seeing improvements in gout flares. And they're also seeing, what was the second outcome that you spotted?
It was about kidney stone risk.
Kidney stone risk. So interesting how all of these conditions, could I say that there is some level of association. There is some level of, like, they seem to be connected in a way that we are, or you are just discovering. And these medications, these newer classes of medications are beneficial for multiple reasons. So I think very interesting work, Natalie. Natalie.
And it's interesting too, because, we're hoping that, one medication might be able to serve a dual purpose. And that obviously can be easier for people in terms of medication taking, in terms of costs.
That was actually my exact line of questioning.
Sorry.
No, Natalie, you knew it.
Yeah.
So, this is really exciting work, because obviously with every medication we take, even though they truly are, the newer classes of medications are revolutions of science. They are absolutely incredible, but we still don't want to be taking, we want to reduce the number of medications. So is the next step in your research in this case to look at more of these effects, so that perhaps in future we can start recommending, instead of taking 2 medications for 2 different kinds of conditions, is the hope to be able to just have 1 medication for multiple conditions?
And the sort of main medications people take for gout is called urate lowering therapy, because serum urate is the main factor that contributes to gout flares. But there's across many studies has been found that there's low adherence to urate lowering medication. And I think, because it is sort of an off and on disease, people may not be as inclined to take the medications regularly. So, it's exciting to think that that could be an option for people who maybe don't have a severe gout. And if they have another reason to be taking one of these other medications, that it could help them in both ways.
Well, Natalie, I hope that is the exact direction that we're heading in, and that we're able to do, like you said, we're able to do more with less medication.
Yeah.
So I want to thank you for your contributions to science. I want to thank you for your mentorship to me, as well as many of the arthritis trainees across Canada. And I really look forward to learning and reading more about your work as it is published. And I want to thank you on behalf of the audience today for your time here with us.
Oh, well, thank you again for having me. And yeah, I hope you've learned a bit more about gout. And
We have definitely, and we have a new perspective on gout, I think. So Natalie, it was such a pleasure to have you. To our audience, we hope you have a great rest of your week, and we hope you join us for another episode of Arthritis Home. Bye for now.